specify the traffics in different class maps, and then we'll be scheduling those packets, how exactly they will be forwarding the traffic here. So what is queuing? The same thing here. Queue is used to store your traffic until it is processed or serialized. Now, what this means is, let's say this is my router, and the router is generally having an input queue. So input queue is nothing but this is input interface. So when the packet is received, so what it is going to do is it is going to store this packet inside the queue, just like kind of temporary memory, we can say, before it actually sends to the CPU. So we call this as input queue. So the ingress queue stores the packets until the CPU is involved, and that CPU will decide where exactly this packet has to be sent. So just like routing or switching, whatever it has to be. Now, once it decides that this packet should be sent out of S1/0 interface, this is my decision as per the routing table. Now, this packet has to be serialized onto the output interface. So it has to send this packet onto this interface. Before it sends, again, it's going to store these packets on the egress queue. So that's what your egress queue. Now, the egress queue is about storing your packets before it actually goes onto the interface, before it goes onto the physical interface, before it actually been passed on to the interface. So there will be some kind of small storage before and after this. And technically, we call them as input and the output queues. So both your routers and the switches have both input queues and output queues. So in general, queues like kind of a temporary memory where exactly it will store the packets before it's being processed or before it's being sent out of the interface. So again, as I said, we have two types of queues, input and output queue. Now in the input queue, it is always first in, first out. So which means we have a router and the router is receiving the packets, and by default, we cannot do anything for that. Whichever the packet comes first, that packets will be processed. So that's the default behavior, and this cannot be changed. So we cannot change the order of the packets, how exactly they receive. But what I can do is, now once these packets are being sent to the input queue, and from there it's being processed. And once the packets are being processed, now this particular is going to send out of this interface S1/0. That's what serialization. So the gap between the CPU and the serialization, that is your output queue. Now this is output queue. Now what we can do is, this output queue is again further classified into two types. We have something called software queue and the hardware queue. Now, this can be categorized as the software queue and the hardware queue. Again, the hardware queue will be first in, first out, which means whichever the packets comes first on this output queue, that will be sent first. But whereas the software queue can be customized. So what I can do is I can customize the software queue, and where I can tell my router to rearrange the packets before you actually send them outside. So how exactly this works is, let's say we got a router, and this router is sending some packets, and let's say we are receiving some packets in a random order. Let's say there's a VoIP packet. These are VoIP packets, let's say. So before that, there is a HTTP packet which arrives. So this is my HTTP packet, and then there is an FTP packet, let's say. So let's say this is the order I received. So I have received the FTP packets first, and then I received HTTP packets, and then I received the VoIP packets. Now again, this will be always first in, first out, as I said. Now the router is going to process those packets, and then it will try to send them out of the queue. So that is your output queue. Now here there are two things we need to know. Now in case if there is no congestion. Now the situation will differ in two types of scenarios. Let's say if there is no congestion, then immediately these packets will be sent to the hardware queue. That's a hardware queue, and then send out of the hardware queue in the same order as it receives, first in first out automatically. Because you don't need quality of service if there is no congestion. So quality of service is only required when there is a congestion, when there is a possibility that the traffic may get dropped. So we need a quality of service. So depending upon the congestion, whether it is there or not. So if the hardware queue is full, like here you can see the condition here, if the hardware queue is full. So if it is not full, means there is no congestion. So it will immediately send out of the hardware queue. It will go out of the hardware queue. But let's say if there is a congestion. So let's again assume that there is a congestion here on the link. Means you are receiving excess traffic than what the queue can hold. Now what it will do is the packets will go to the software queue before it goes to the hardware queue. Now inside this software queue, what we can do is we can rearrange your packets. So what we'll be doing is here inside the software queue, as the packets are received, we'll say VoIP packet should be sent first, and then your FTP packet should be sent first, and then your HTTP traffic should be sent. So this is kind of rearrangement of your packets. And once you rearrange, again, you will send to the hardware queue and your packets will be sent. And in case if there is any delay, most likely your HTTP packets may impact, but your priority packets will be always sent first. And that's what we are trying to do in our congestion management mechanism, congestion control mechanisms. With the help of queuing, what we are doing is we are going to rearrange your packets in different classes or different traffic flows. And then we are going to tell that this should be given a priority, this traffic, whereas this particular traffic should get this much of bandwidth, this much of bandwidth. And in case if this exceeds, you can again configure policing. You can tell to drop the traffic. So that's exactly the difference. Like here, the same point what I have just explained, the same thing here. Full hardware queue indicates congestion. So whenever this hardware queue is full, it actually indicates that there is a congestion. And if there is no congestion, then it will bypass the software queue. Means it will simply bypass. There is no need to do any kind of queuing mechanisms. It is not required if there is no congestion. So again, hardware queue, as I said, it will be always first in, first out. And again, the software queue is something we can modify. So this again depends upon the platforms and the versions. These options will slightly vary. So we can create multiple queues and we can define priority for our traffic based on those specific queues. So if you want to verify these queue sizes, now again the hardware queue size, it will vary depending upon the platforms and the iOS version. So probably there is one simple option you can use, show interface F0/0. You can see normally there is the input queue and the output queue, the number of packets it can actually hold. And this will vary based on the speed of the interface. So the link speed as well as the platforms and the versions, these values will vary. So again, there are specific commands you can use to change these default queue sizes. Again, not recommended. You can just go with the default, but we can change the input queue or output queue with these values on the specific interface.